The last lecture that we will have would be on chapter 16, would be on the reflex arc. When we look at the reflex arc, the first thing that we should mention is going to be, what is a reflex? It's a rapid automatic reaction to a stimulus. The response should occur the same way every time. There's very limited neurons that are involved, so what we're looking at is that there should be synaptic delay, but it should be minimal. And your synaptic delay is going to be based off of whether we see here in a polysynaptic reflex an interneuron, which will increase the synaptic delay, or when we look at a monosynaptic reflex, we see that an interneuron is lacking. So the delay is still present, but it's a lot less or minimal compared to a polysynaptic reflex or delay. One of the things that we do look at with reflexes is the components. The first thing that's always going to happen is there's going to be a sensory receptor. For example, here we're looking at the muscle spindle, a sensory stretch receptor. The impulse will then travel to the central nervous system or the spinal cord. So once it enters in through the sensory neuron into the central nervous system, sometimes there's an interneuron process, such as in the polysynaptic, and sometimes the interneuron is missing in the central nervous system, which causes minimal delay in the action potential. But what we should see is that then the motor neuron, once the information is sent from the sensory, we should see the impulse traveling down the motor neuron and eventually to an effector to elicit a response, which in this case would be kicking the leg out. When we're looking at the difference between monosynaptic and polysynaptic responses, again, when we're looking, this is a direct communication, so we're missing the interneuron. There's very minor synaptic delay, and this just increases the reflex response or the effector organ, in this case, kicking the leg out. The polysynaptic is a little bit more complex. The complexity is based off of contralateral. In this example, what we see is on the same side, which would be an ipsilateral response. So we see the hand touching the flame. The information is traveling through the sensory neuron. It's communicating with an interneuron to the motor neuron, and on the same side we should see the effector organ or the bicep pulling the hand away. This polysynaptic reflex can occur in contralateral situations, such as you stub your left toe on a nail. The information travels into the interneuron, connects into the motor neuron, and then the effector would actually be on the right side of the standing leg. So it can occur either on the ipsilateral for this example, or a contralateral, which means just simply the opposite side. When we're looking at an example of a monosynaptic reflex, we have here is a picture of a muscle spindle. And some important aspects of the muscle spindle is, first, this is considered to be a stretch reflex. When we're looking at monosynaptic reflexes, again, the interneuron would be missing. So we have some connections between the alpha motor endings of the extrafusal fibers. So here, these alpha motor nerve endings are connected to the extrafusal muscle fibers, and when I say connected, they communicate. And then the gamma motor neurons are connected with the intrafusal muscle fibers. So one of the things that we look at first with the alpha motor neurons here is that the alpha motor neurons directly affect the lengthening or shortening of muscles by stimulating the extrafusal muscle fibers. When we look at the gamma motor neurons, they're important in keeping the muscle spindles taut by stimulating the intrafusal muscle fibers, leading to a muscle contraction. So these different intrafusal and extrafusal muscle fibers are going to be evaluating the stretch or the amount of stretch that occurs. And if the stretch becomes too great, then the alpha and gamma motor nerve endings of the muscle will cause the intrafusal and extrafusal muscle fibers to contract. So if we have this sensory monosynaptic reflex, if this stretch reflex gets activated, then what we see then is going to be the contraction. The best example is a sprinter running a 100-meter dash. They overextend the leg and causing the hamstring to cramp or contract. That's the easiest way to kind of remember how these work. And then the other one that we have is a polysynaptic reflex, which, again, when we look at a polysynaptic reflex, what we're going to see is that this Golgi tendon organ, which is located at the end of the tendon of any muscle, is going to be polysynaptic. It's going to send the sensory information up into the central nervous system, and then it is going to connect into an interneuron. So the synaptic delay is a little bit longer in this reflex, polysynaptic reflex. The only difference is once the interneuron is activated, it is going to inhibit the action of the motor neuron. So once we see the interneuron, we will not see that information going into the motor side. So what we see is more of an inhibit, or it does inhibit the motor neuron response. So we should not see any motor response coming back down to the effector. In this case, we could just call this the quadricep. Therefore, what we see is a relaxation. So with the muscle spindle, we saw a contraction, and on this polysynaptic reflex, we should see a relaxation. So again, Golgi tendon organ, once the muscle gets stretched, causes it to communicate with the interneuron. It blocks or inhibits the motor neuron response, so we don't see a response coming back down to the muscle, and therefore it allows for the muscle to relax. We see this in any stretching exercise, like simply touching your toes, multiple bouts eventually of touching your toes. The Golgi tendon organ will slowly relax, allowing you to go further or deeper into your stretch. This is just some clinical important reflexes. So you have more than just the monosynaptic reflex, like the stretch reflex of the patellar jerk, or the different types of reflexes like the stretch reflex or the Golgi tendon reflex. So you find these associated with the spinal segments. And again, reflexes are important because it checks the overall integrity of the spine. So we're really looking at, when we're activating a bicep reflex, we're really looking at the overall health of the spinal cord at C5 and C6. So if we we tap the bicep brachii tendon, we should see a flexion of the elbow. When we're looking at the tricep response, we're looking at C6 and C7. Abdominal responses, mostly we're looking at T8 through T12. This can be activated by just briskly stroking the abdominal side. The patellar knee jerk reflex, we're looking at L2 to L4. Again, it extends the knee when the patellar ligament is tapped. The ankle or the Achilles reflex, we're looking at the overall health of S1. When the calcaneal tendon is tapped, we should see plantar flexion. And then we see plantar reflex, which is L5 through L5 and S1. The plantar foot flexes, flexes toes when the plantar side of the foot is briskly stroked. So when we touch or stroke the plantar side of the foot, we should see the toes actually flexing. So these are just some clinical importance. The most important aspect is we're just looking at the overall spinal nerve, communicating with the spine for all of these. So we're looking at normal responses, mostly in adults, checking on any spinal cord damage or any compression that's going to inhibit sensory to a motor response. Thank you, and I will talk to you soon.